Okay, so now we are going to learn how to differentiate or to find the derivative of a function. So how we do that, in this case, we're given y. So y equals to 3x squared plus 10x. So to find the derivative here, we just say dy over dx. So we are differentiating y with respect to x. Okay, so in our first term here, we have 3x squared. So what we do, we look at our variable, which is x, and our exponent, which is what, 2. So we take this exponent, which is 2, and multiply it with the coefficient of the variable. So we'll have 6x. So what we do here with the exponent, we need to minus 1 each and every time. Okay, so also on this second term here, which is 10x, what we need to do to find the derivative, we need to make sure that we remember that your x variable is to the power 1. So 1, which is your exponent, times your coefficient, which is 10, is 10. And then each and every time you need to remember to minus 1. Okay. And then when you simplify this, you'll have 6. 2 minus 1 is 1. You can just leave it as it is. And then 10, 1, x, 1 minus 1, you'll have 0. Okay, so 6x plus 10 will be your final answer after you find your derivative. Okay, and then moving on to the next one. So the next one, we are asked to determine the derivative of this function f of x. So it's very important to check if you have all the terms written in a proper exponential form. So all the terms are having the variables are having exponential form. So we can find the derivative. So the derivative for f of x, so is f prime x. So on the first variable here, we have 2x squared, right? So how we find the derivative, we take the exponent here, which is 2, we multiply it with the coefficient here, which is 2. So it's 2 times 2 here, and then you'll have 4. So each and every time when you differentiate there, you need to remember that you minus 1 each and every time. And then with the next variable here, you have x to the power 4 and half here. So what you do, you take your exponent again here, which is 4, and you multiply with the coefficient of x here, which is half, right? So it's what you'll have 4. Okay, so you'll have 4 multiplied by half, and then each and every time, please remember to subtract 1. And then for the last term here, which is minus 3, so the derivative for this will be 0. So each and every time when you have a constant, when you find a derivative, it will always equal to 0. Okay, so the next step is to simplify this. So if you simplify this, you have 2 minus 1, which is 1, and then 4 times half, which is 2, and then you have 4 minus 1, which is 3. Okay, so this is your final answer after you differentiate. Okay, so the next one, you are asked to determine the derivative of g of x. So you are given g of x here, but if you can look, you have 5x squared minus 2x divided by x cubed. So before you apply your derivative, if you have a fraction like this, please try to simplify this first and get it into a form where you can find your derivative without any fractions. So how can we do that here? So we can try to simplify this. So we have 5x squared and then 2x divided by x cubed. You can clearly see that you will divide here. One of the x's will go here, so you'll have 2 here, and then the 1x will go. And then now you'll have 5x squared minus 2 divided by x squared, right? So you don't want your fractions, you want to have only numerators if you have, but not a denominator here. So you need to remember your exponential law. If you are having your x, or you are dividing with your x squared, you need to remember your exponential law to remove it from being a fraction. So we can apply that now. So your 1 over x squared can be written as x to the power negative 2. So this is from the exponential law with the rule of 1 over x squared is the same as 2 to the power negative 2. So you just apply that rule. So this is the same as 1 over x squared. So we converted it to be x squared x minus x to the power negative 2. Okay. So now we can apply the rules of differentiation. So the derivative for g of x is g prime x, which is what? The first derivative here, which of 5x squared, we take the 2, we multiply it with the 5, and then we'll have 10, and then we need to remember 2 minus 1 each and every time. Okay, and then the next one, we do the same. Our negative 2 will multiply the coefficient here of negative 2, so we'll have positive 4. And then each and every time when we do that, we need to minus 1 on our exponent. So the next step is just to simplify. So we have 10x, 2 minus 1, so it's to the power 1. Can just leave it like this. And then plus 4x minus 2 minus 1 is minus 3. So this is the final answer for this question. Okay, and then number D, we are asked to differentiate again. So in this case, we're given f of x equals to minus 3x squared plus 5 square root of x. Yes. So the first step before we find the derivative, or before we get the derivative here, we need to try to remove the z. So remove the z here, which is the square root of x here, to be in an exponential form. So how do we do that? We need to remember the rules of surds, how to convert a surd to exponent. So if you are, for example, you are given a surd of square root of x, so square root of x, when you convert it into its exponential form, you'll have x to the power 1 over 2, right? So if you are given cube root of x, right, is the same as x to the power 1 over 3. So this is the rules of the surds that you studied in grade 11. Okay, so let's apply that now. Okay, so for the first term here, when you find, before you find any derivative, you can just leave it as it is here. And then for the second term here, which is 5 square root of x, you can try to convert it first before you apply your differentiation using your surds and your exponential rules. So square root of x is the same as x to the power 1 over 2. Okay. Okay, so now that we have expressed this equation into its exponential form, we can find the derivative. Now the derivative for f of x will be, we apply the derivative laws. So your 2 here, which is your exponent for x, will multiply with your negative 3 here. So you'll have minus 6, and then we need to remember to minus 1 each and every time. And then also for the second term here, we have to the power half. So this half here needs to multiply the 5 here. So we'll have 5 over 2. And each and every time we need to remember to minus 1 each and every time. Okay, so when we simplify this, our f derivative will equal to minus 6x. So 2 minus 1 will be just 1. And then we have 5 over 2. And then we have 1 over 2 minus 1. So if we simplify this, we'll simply get minus 1 over 2. So now we have found the derivative for f of x, okay? And then number E, how to find the derivative for f of x here. So in this question here, we need to remember what does this mean. So this means that we are squaring it, right? So if we square something, for example, if we have x squared, this is the same as x multiplied by x, right? So we need to apply that rule first before we find the derivative. And also, we don't need the fractions. We don't need fractions as well. So let's first expand this. So x minus 3 over x, and we are squaring everything. So we can rewrite this as x3 divided by x multiplied by x minus 3 divided by x, okay? And then now we can just FOIL this. So your x times x will be x squared. And then your x times negative 3x divided by x. So you'll have minus 3. And then negative 3 divided by x times x, you'll also have minus 3. And then minus 3 divided by x times minus 3 divided by x, you'll simply have 9, positive 9x squared. And then now we can just simplify this. We'll have x squared minus 6 plus 9x squared. Okay, so remember we said that we don't want to be dividing by your variables, so we can also convert this one from being a fraction to become just a numerator only. So we are dividing by x squared. So from our exponent's law, we know if we are dividing by x squared, these can be converted to be x to the power negative 2. So we apply that rule here before we do any differentiation. So it will be x squared minus 6 plus 9x minus 2, right? So 9 to the power negative 2. Okay, so it's very important for you to note that. So now we can apply our differentiation. How do I apply our differentiation, or how do we show it? We show this as f prime again here. So the first term here, so we have x squared. So x squared, we take the 2, multiply with the coefficient here. So it will be 2x, and then the 2 minus 1, okay? And then the derivative, the next one is negative 6. So the derivative of a constant, we know it's 0. So we'll just write plus 0. And then the next one, we have what? The 9x to the power negative 2. So negative 2, we need to multiply it with 9. So we'll just have minus 18. Okay, and then we need to also remember to minus 1. Okay, so if we do that, we simplify this, we'll have our 2x. When we simplify this, so 2 minus 1 will be just 1, plus 0, and then minus 18. So minus 2 minus 1 will be just minus 3.